quadratics and the real world. And we're going to talk about some real world problems, how to look at a graph, how to gather some information from looking at a graph of a parabola based on the real world. So, from 4 feet above a swimming pool, Susan throws a ball upward with a velocity of 32 feet per second. The height, h of t, of the ball, t seconds after Susan throws it, is given by the function h of t equals a negative 16t squared plus 32t plus 4. Find the maximum height the ball reaches and the time that this height is reached. Okay, so we're looking for the maximum height and the time. Okay, the first thing you want to do, we're going to sketch a graph of our parabola. The first thing you want to do is you want to know what does the x-axis represent and what does the y-axis represent, because that's really important when you're looking at different points and stuff. So the first thing we're going to see is this h of t. Okay, h of t is the height. Okay, so that's our height. We've talked about how f of x and y are the same thing, so this is our y value. So our y-axis is going to represent the height of the ball. Okay, the x here, when we plug it into our calculator functions in x and y, so our x value is going to be the t. We're going to plug in our x for t. So what is x going to represent? What does that t represent? The t represents the seconds, or the time, and we'll write it in seconds so that we know what our parabola is talking about, what it looks like. Okay. After you label your x and your y values based on the word problem, then we're going to graph our function. So always label your x and your y values based on the real world measurements. So we want to make sure that our time, we know that it's in seconds. What is our height going to be? Well, here it talks about 4 feet above the swimming pool, 32 feet per second. So that's going to be in feet. We should label that as well. Okay. So the next thing we're going to do, figure out what part of the parabola or part of the graph is going to be important to look at. Okay. If we're looking for the maximum height, we're going to want to know what the maximum is. Okay, so we are going to be looking for the maximum value. Another one you could look for is the minimum. Another one that might be important is the y-intercept. Another one that might be important is the x-intercept. And we'll go from there. Okay. After you figure out what we're going to look for, we're going to be looking for the maximum. Okay. Then you can graph the function. And then we're going to have to figure out how to zoom, because a lot of these functions won't be nice and pretty in our window at first. And then we're going to have to figure out how to analyze the graph. So what part of the graph do we want to look at? Okay, so let's go back up here. I'm going to plug this into my calculator. When I plug it into my calculator, I'm plugging in that negative 16t squared, but instead of t, I'm going to plug in x. Okay, so the next thing I'm going to look at here, this is the function that I plugged in. I got a negative 16x squared, because your calculator won't know what to do with t, plus 32x plus 4. When I graph this, this is what my graph looks like. Okay. Now notice this is a really skinny parabola. And it shoots off the graph. If you guys are not done graphing it, you need to pause the video, get it graphed on your calculator. On your mark, get set, go. Then we want to figure out how to zoom, because we want to see the whole parabola. So we're going to hit menu. If you go down to window zoom, so option number 4, then we can either, a couple things you'll use, you can zoom in, you can zoom out. If we do zoom out, if you hit 4, Then it's going to ask for the center. I usually do it from the middle of the graph. If I zoom out enough, there's the parabola, okay? If you want to get a little better picture, we can hit menu. We can hit 4 for zoom, and you can do a box zoom, okay? That's option number 2. We can hit enter, and basically we're zooming in from a box. You're selecting what you want to zoom in on. So I could hit up here and draw my box down to about here, and it'll zoom in the parabola a little bit further. Okay. From here, the next thing you want to do is sketch it on your paper. So we have something that looks like this. Woo! Okay, that's what our parabola looks like. The important part for us is the maximum height and the time that it takes. Okay, so our maximum height would be this first. Sorry about that. Our maximum height would be this tallest point. Okay, so we can go back to our parabola. We can hit menu. We can analyze the graph, and we can say, hey, would you find that maximum point for me? So if we go to menu, option 6, option 3, hit enter. You have to move to the left, hit enter, to the right, hit enter, and that maximum point is 120. Okay, so our 120 is our vertex. That's our maximum point. From here, you need to know our x is 1, our y is 20. So what does that mean in the real world situation? Well, 1 is, x represents time. So that 1 is after 1 second. Okay, after 1 second, it hits a height of 20. So the maximum height is 20 feet after 1 second has gone by. It's nice to try to answer these in complete sentences so that you know what the 20 represents, what the 1 represents. Okay, we're going to pause there. Okay, let's look at another one. Here, it says that a financial analyst determined the cost of producing bicycle frames is represented by this function here. So this function represents, what do you think the C is going to stand for? Okay, this here is our cost of producing so many bicycle frames, where F is the number of frames produced. Okay, so F equals number of frames produced, and C is the cost in thousands of dollars, so we want to make a note there. C is the cost in thousands of dollars. And it says find the number of frames that minimizes. So we're looking for number of frames that minimizes the cost. And then we also want to find the total cost it would take to produce that number of frames. So the next thing we're going to do is look at that graph. When you plug it into your calculator, you can use, if you want to plug in a fraction, you can hit Control Divide. So if I were you, I'd plug in find a new graph page. We're plugging in this function. Okay, instead of F, we're plugging in X. So we have 1 over 40,000. That has 1, 2, 3, 4 zeros. Make sure you're plugging in 4 zeros. I want you guys to plug this in your graph as well. So if you're not plugging it in, hurry up. Times x squared minus 1 over 25. Again, you can hit Control divide to get a fraction bar. So 1 over 25x plus 40. If y'all need more time, pause the video. From here, we're going to plot it. When you hit enter, when you hit graph, your graph should look like this if it's not zoomed out. Okay, so the next thing you need to do is you need to zoom out your graph. So we can hit menu, we can hit zoom for, I usually always start zooming out to see what happens, so I'll hit 4 here, and you can hit enter. When I hit enter once, this is what my graph looks like. You can keep hitting enter. When I hit enter again 3 times, I start looking like that. This is after I've hit it 4 times, 5 times, 6, 7, 8, 9, 10, 11, 12. I've hit enter 12 times, and this is what I get. Okay, so from here, we want to figure out what does our x value represent, what does our y value represent. That's the zoomed out version. You could zoom in if we wanted to do more zooming, you could. That's going to be fine for now. So what I would do here is sketch that graph. Looks like this. Okay. What does our y value represent? What does our x value represent? You always want to label that. So the y value was what we plugged in here. That was our cost in thousands. What did our x value represent? What do we plug in for x? That was our f. F was the number of frames. Okay. The next thing you want to decide, what are we looking at on our graph? Well, if we're trying to find the number of frames that minimizes the cost, okay, we're looking at how many frames can we get to minimize the cost. That's going to be our lowest point on our graph, okay? We don't know exactly where that is. So on our graph, what we'll go to is we'll go to menu, we'll go to analyze graph, option 6, and we're going to ask it to find the minimum value for us. I go to the left and to the right, and then it'll show us this point right here is the minimum point. Okay, it looks like it's on the x-axis, but it's not. It's just because we're zoomed out so far that it kind of looks crazy. So that minimum point is 824. So if I label it 824, we got to know what that 800 represents and what the 24 represents. So 800 is the x, 24 is the y. So what does the x represent? What does the y represent? Well, the x represents the number of frames. The y represents how much money it costs to make those frames. That's $24,000, because that's a cost in thousand. So if they make 800 frames, since that's the lowest point of our parabola, that's the minimum cost it's going to take. So we could say 800 frames cost $24,000 to make, which, can't spell, wow, which is the lowest number of frames at the lowest cost. That would be a good complete sentence to use there. Okay. If you need more time to copy that, pause the video, let the kids copy this. All right, I'm going to move on. Next word problem. Competitors in a 10-meter platform diving competition jump upward and outward before diving into the pool below. The height, h, of a diver in meters above the pool after t seconds can be approximated by the equation h equals negative 4.7 t squared plus 3t plus 10. When will the diver hit the water? Okay, so if we sketch our x and y axis, this is our y, this is our x. What does the y-axis represent? Well, here, the t we would plug in for that's what we would plug in for x. The h represents the height of a diver in meters. So we can say height in meters. X is the time in seconds after the diver has jumped off the platform. Okay, so we're going to plug this into our calculator. We're going to plug in an x instead of a t. So when you plug that in, you should plug in negative 4.7 x squared plus 3x plus 10. Go ahead and plug that into your calculator real quick. Pause if you need more time. When you plug that in, you should have a parabola that looks like this. We can zoom out, we can hit menu, window, we can hit zoom out, option 4. You probably only need to do it once and you get a pretty good graph like that. If you want to use box zoom, you can hit menu, window zoom. You could do zoom box, and that just means you need a, like if I wanted to zoom from here to here, it would zoom me in that way, and I'd get a prettier parabola that looks like this. You don't have to, but you can if you want. I just hit Control Escape to undo that zoom, so that's where I'm at right now. Okay. Now if I sketch that on my paper, it'll look something like this. Okay, just sketch it, get an idea. It says the question that we're answering is not how high. The vertex would tell us how high the diver jumped off the platform, the highest point of the dive. It asked us when would the diver hit the water. Okay, since y represents the height, we're looking for this point right here would be when the diver makes the splash into the water. Okay, so we're looking for not the height of that, because we know the height of that is 0. The diver would hit the water at 0, but we're looking for the time, like how long would it take the diver to jump off here and finally hit. That time, what variable represents time? It's our x. So we would be looking for what is the x value of this point right here. Okay, so when I'm looking on my graph, I'm trying to figure out what that point is right there. If you notice right there, it's not at an exact point. So if we go to menu, if we go to analyze graph, what selection might be a good one to look at? Well, since it's crossing the x-axis down here, that's what we call the 0 of the function. Your y value is 0, but your x value will be something. That's what this 0 is talking about. So if we select option 1 here, then you can go to the left and to the right of that intersection, and it'll give you the point that goes along with it. Okay, this point is a positive 1.810. That means the time x, the x value, is 1.81. And the y value is 0. So after the diver hits the water, has a height of 0, that's how much time has passed. So when will the diver hit the water? The diver will hit the water after 1.81 seconds. After 1.81 seconds, because that was our x value of that point. That's our answer there. If you guys need to pause the video and then pick back up tomorrow, you can. We can work through this next one tomorrow, or if you have time in class right now, finish it up. Your call. On this one, we have the shape formed by the main cables of the Golden Gate Bridge approximately follows this equation. What is the vertex and the y-intercept of this graph? So basically they're saying we've got a Golden Gate Bridge that has cables, and this is what your bridge looks like. Here's your bridge right here. Here's the little cars going on the bridge. Don't make fun of my car drawing. Woohoo! Okay. It's talking about these cables right here make this parabola shape. It just asks for the vertex and the y-intercept. So all you have to do is plug this into your calculator, find the vertex, and find the y-intercept. So when you plug this into your calculator, you get a graph. When I plug that in, you're going to plug, just make sure you get all the zeros in. 0.0002 x squared minus 2.3x plus 227. When you graph it, your graph looks like this. You got to zoom out. So menu for zoom out. You're probably going to have to zoom out a lot until you start to see the graph. I probably clicked it 7 or 8 times. This is where your parabola is. Now it's asking us for the vertex, and it's asking us for the y-intercept. Okay. How would you find the vertex? Well, does this graph have a minimum or a maximum? It has a minimum. So we could hit menu, analyze graph. We could go down to minimum because it has a lowest point, hit minimum, and go to the left and to the right of that lowest point. And it would tell us what the vertex is. 575, 161. So our vertex, we say the vertex is 575, 161. And then we'll write, and the y-intercept is, and we'll fill that in a second. How would you find the y-intercept? Well, from standard form, if it's x squared and then an x and a number, we know from our composition notebook, the notes we took on Monday, how did you find the y-intercept? Okay, the y-intercept was the number that was always added at the end. If it's in standard form like this, it can't be in vertex form. Vertex form is this. That does not give you the y-intercept. That's in vertex form. But if it's in standard form, it has ax squared plus bx plus c. It's in standard form. That means the y-intercept is that number that's added at the end. So the y-intercept should be when x is 0, the y value is 227. Another way to find that on your calculator, you could hit Control T and go to the table and look for where is x 0. Wherever x is 0, that's where the graph is going to cross the y-axis. And look, there's the 227. Okay. That's all the word problems for today. Have fun working on your assignment. That transformations with quadratics assignment that you hopefully got yesterday. This is what it looks like. That second page is quadratics in the real world. So number 1, 2, 3, 4, 5, and 6 are all just applying stuff to the real world. Okay. If you have questions, ask. Have fun.